So when graphing systems of equations and we're trying to see if they have a solution, there are three types of systems that can occur. For example, lines that have one point of intersection only have one solution. Visually, that will look like one line. Let me say this line here, that steady slope, intersecting with another line. I'm going to have it intersect here. Just have it have the same slope but negative. Right? These 2 points, or these two lines, intersect at this one point. And this one point is the solution. Another option when you graph two lines is that they might be parallel. So for example, it could start at 1 and then have a slope of 1 going up for my first line. And my other line maybe could start down here at -1 and have the same slope of 1. Right? So these two lines never intersect. So there is no solution here because they never intersect. And last but not least, the third possible way or solution you could get when you are graphing two lines is you could actually graph the same line. For example, you could start with a line that has a y-intercept of -3 and a slope of, let's say, 3/2. So if I wanted to graph that line, I would start at -3 and I would use my slope up 3/2 and I would graph this line. You might also graph another line, maybe it's in standard form, and you find out that its y-intercept is at -3 and its x-intercept is at 2. And when you graph that line, you realize it lays right on top of the first line that you graphed. So if you think about it, there are so many points, an infinite amount of points along this infinitely long line that these two lines have in common. Therefore, there are infinite solutions. So let's try a few practice problems to see how this can occur when solving systems by graphing.